Okay, let's talk about this rule you hear a lot in product development. You know, the one that says 5 users are enough.
Right, the 5 users find 85% of problems idea. It's everywhere.
Exactly. But, well, what if those problems aren't just like annoying website clicks? What if it's a medical device?
Then suddenly that guideline feels, well, a bit shaky, doesn't it?
Yeah, it feels pretty risky.
And that's what gets highlighted in fields like medical devices. Manufacturers are always doing this balancing act
Uh-huh. Between what?
between keeping testing costs down, sticking to schedules, but also needing like really solid proof for regulators. Proof that the device is safe, that it actually works for the people using it.
Because the stakes are just so much higher if something goes wrong.
Precisely. A design flaw isn't just inconvenient, it could be dangerous.
Okay, so for this deep dive, we've gathered some really interesting research that kind of pushes back against that 5-user thing.
Yeah, we're looking at studies that dig into how effective usability testing really is.
And what actually influences how many problems you find and, how many users you really need to be confident.
And the sources we have offer different angles on this, different models, different perspectives. It's not just one simple answer.
Right. So our mission here is really to get under the hood of this whole thing.
Yeah, we want to unpack why that 5-user rule even started, where it falls short.
Especially for critical stuff like medical devices.
Exactly. And figure out what really matters when you're deciding, okay, how many people do we actually need to test with to find the issues that count?
All right, let's start right there. That famous 5-user rule. Where did it actually come from?
Well, the basic idea behind it is return on investment, ROI.
Okay.
The thinking is, you get the most value, the most bang for your buck from the first few tests.
Because they find the obvious stuff.
Yeah, exactly. Those first users tend to hit the big common problems. Then, as you add more testers, you start seeing fewer new issues pop up, diminishing returns.
Makes sense.
The study everyone points to is Nielsen and Landauer back in '93. They crunched some numbers and estimated that, on average, just one user would find about 31% of the usability problems.
Okay, 31% per user. So if you do the math, you test 1, 2, 3, 4, 5, you get up to around that 85% mark. Sounds pretty good on paper.
It does, doesn't it? But, and here's where our sources start raising flags. That 31%, it's just an average. And later research showed it actually varies, like a lot. The standard deviation was pretty significant, around 0.12, I think.
Wow. Okay, so it really depends on the specific product, the specific users.
Hugely. It depends on the interface, who you're testing with. Relying on that single average is, well, it's a bit simplistic.
Like assuming everyone wears the same shoe size.
Right.
It just doesn't work like that.
Exactly. And another big simplification in that model, it treats all problems the same.
Ah, right. But a typo is not the same as a critical dosage error.
Precisely. A minor visual bug versus something that could cause serious harm on a medical device, totally a different ballgame. Missing a cosmetic issue is one thing. Missing a safety flaw, that's critical.
Yeah, you can't afford to miss those critical ones, even if they're less common.
And there's another wrinkle. The feeling you get like you're finding almost everything, that can actually depend a lot on who you happen to test first.
How so?
Well, if your first few participants are just really good at spotting problems, you might think, great, we've found most things. But maybe there are other trickier issues that only different types of users would run into.
So early success might give you a false sense of security.
It definitely can. So, okay, if 5 isn't the magic number, what are the big factors we should be looking at? What really drives how many people we need?
Good question.
One huge factor is user heterogeneity.
Heterogeneity, meaning how different the users are from each other.
Exactly. Think about everyone who might use your product. Different experience levels, different backgrounds, different ways of thinking about things. If you've got a really diverse user base, well, you'll probably need more testers to find the wide range of problems that these different groups might encounter. Different people just stumble on different things.
That makes total sense.
Yeah.
A power user spots different issues than a complete beginner.
Right. So the takeaway for testers is know your users. Don't just get anyone, get a representative mix.
Crucial. What else?
Then there's visibility variance. Simply put, some problems are just harder to spot than others.
Ah, okay. They're less obvious.
Yeah. That original 31% average kind of assumes all problems are equally easy to find. But what if the really dangerous ones are subtle or only happen in specific, rare situations?
Then you'd need more people testing just to increase the odds of someone finding it.
Exactly. Models that assume equal visibility can seriously underestimate how many testers you need for those harder to find but maybe critical issues.
So it's not just how many problems, but how visible they are. Got it.
And this next one is maybe the most fundamental, your user selection criteria.
How you choose who to test with.
Absolutely. You have to make sure the people in your test actually represent the people who will use the product in the real world.
Because if you test the wrong group,
Your results could be totally skewed. You might find problems that aren't relevant. Or worse, miss the ones your actual users will face. Adding more of the wrong users doesn't help. It might even muddy the waters.
that's a huge point. Testing a complex medical app with, I don't know, a bunch of software engineers tells you almost nothing about how an elderly patient under stress will use it.
Precisely. And finally, think about task complexity and the testing environment.
Right. What are you asking them to do and where?
Test in a simple website, maybe one core task in a quiet lab. You might get away with fewer users. But testing a complex medical device, multiple functions, maybe used in a noisy hospital ward, under time pressure, maybe coordinating with others.
That's a whole different scenario.
Absolutely. That complexity almost guarantees you'll need a larger, more diverse group to find the range of issues that could crop up in real use.
Okay, so clearly 5 users just doesn't cut it as a universal rule. Now, you mentioned our sources look at some mathematical models to try and estimate the right number more scientifically.
Yeah, they do. Researchers have definitely tried to move beyond simple rules of thumb and develop more data-driven ways to figure this out.
How do those work generally?
Well, the early ones, like that geometric series model related to the 5-user rule, they're based on that diminishing returns idea we talked about.
Okay.
But their big weakness is they often assume, first, that all problems are equally likely to be found.
Which we know isn't true.
Right. And second, that we somehow know the total number of problems out there before we even start testing.
Which seems circular. How can you know the total before you find them?
Exactly. It's a bit of a paradox. So to deal with not knowing the total number, statisticians use techniques like the good Turing adjustment.
Good Turing.
Yeah, it's a way to estimate the number of unseen problems based on how many problems you've only seen once, twice, etc. in your sample so far. It's a smoothing technique.
Interesting. So it tries to predict what's still hidden.
Kind of, yeah. And then you get into more advanced models, things like zero truncated distributions or the logit normal binomial model.
Okay, getting technical now.
Yeah, a bit. But the core idea is that they try to account for that visibility variance we talked about, the fact that some problems are just harder to find. They don't assume all problems are equally discoverable.
So they're trying to be more realistic about how problem discovery actually happens.
Exactly. Many of these models focus on calculating something called the p-value.
Not the statistics p-value, right?
No, different context. Here, p is the estimated discovery likelihood, the probability that any single user you test will encounter a specific problem, or sometimes the average probability across all problems.
Okay, so you estimate that probability.
And once you have an estimate for p, you can then mathematically project how many users you'd likely need to test to reach a certain goal for problem discovery.
And how do you set that goal? How much discovery is enough?
That brings in the discovery threshold, often called DLEF.
Discovery threshold.
Right. It's the percentage of usability problems you're aiming to find. And that really depends on the product's risk level.
Makes sense.
For, say, a standard consumer app, maybe finding 80% of the issues is acceptable. You can live with some minor glitches slipping through.
Okay, 80% for low risk.
Yeah.
But for our medical device example,
Much higher. You'd be looking at maybe 97%, 98%, maybe even pushing for close to 100% for really safety-critical functions. The acceptable level of missed problems is tiny.
so practically aiming for 80% means you accept that maybe 20% of issues, hopefully minor ones, might remain.
That's the trade-off, yeah. But for medical devices, that trade-off looks very different. Missing even one critical issue could be catastrophic.
The difference in risk tolerance is stark. So achieving those super high thresholds, like 97% plus, must require a different approach.
It often does. It usually requires a more flexible, iterative process. One approach mentioned in the sources is the grounded procedure, or GP.
Grounded procedure, how does that work?
It's basically testing in stages. You start with an initial group of users, maybe 5 or 8 or 10.
Okay.
And as they test, you don't just list the problems. You carefully track which users find which problems and how often each problem pops up.
So you're gathering more detailed data on the discovery process itself?
Exactly. This lets you calculate an initial estimate of that average discovery probability, P, for your specific product and user group. And crucially, You also assess the homogeneity of the findings.
Homogeneity, meaning are users finding the same problems or are they all finding different things?
Precisely. If most problems are being found by, say, over half your users, that suggests a more homogeneous discovery pattern. If lots of problems are only found by one or two users, that's heterogeneity.
Okay, so you do this initial analysis, then what?
Based on that data, the estimated P and the level of heterogeneity, you use the statistical models we talked about to refine your estimate. You project how many more users you might need to reach your target discovery threshold.
I see. It's iterative.
Yes. Then you make a call. Based on the model's prediction, your budget, your timeline, the risk level, do you stop? Or do you recruit another batch of users and repeat the analysis?
So if you see that new users are barely finding any new critical issues, you might stop, even if a model says you need more.
Potentially, yes. Or conversely, if you're still finding lots of new problems, especially unique ones only seen by one person, that high heterogeneity.
That's a big red flag.
It's a strong signal you probably need more testing, or maybe you need to revisit who you're recruiting to make sure you're really covering the diversity of your user base.
That heterogeneity seems like a key indicator that you haven't seen the whole picture yet.
It really is. Whereas if the sample seems more homogeneous, most problems found by many users, you might feel more confident that you're nearing saturation.
This feels much more dynamic and, well, smarter than just picking a number up front and sticking to it.
It's about actively monitoring and adapting as you go, being a detective during the testing process.
Okay, so moving away from the pure statistics and models for a second.
Hmm.
What about the manufacturer's perspective? The business side. There's a cost to all this testing.
Absolutely. And that's where the value of information, or VOI, approach comes in. It's mentioned in one of the key sources.
Value of information, okay.
This framework looks at it from the manufacturer's viewpoint. It tries to find the sweet spot, the optimal sample size, by balancing the cost of doing more testing against the value of the information you get from it.
And value here means fewer problems later, reduced risk.
Exactly. It's about the potential financial benefits of finding and fixing issues before launch versus the cost of the testing itself.
So it's an economic calculation, fundamentally.
In many ways, yes. It forces you to think about the potential costs of usability failures. They distinguish between acceptable errors.
Like minor bugs, things that might lead to customer service calls.
Yeah, maybe things leading to reimbursement requests, support load, minor frustration, annoying but manageable, versus unacceptable errors.
And for medical devices, those would be...
Things that could lead to actual patient harm, serious adverse events, product recalls, loss of market access, huge reputational damage. The really big, costly failures.
The stakes are incredibly high there. So the VOI approach weighs the cost of finding those potential unacceptable errors against the enormous cost if you don't find them.
Precisely. It's about making an informed business decision, but one that's deeply intertwined with safety and risk. For a medical device maker, an unacceptable error isn't just bad PR, it's a potential patient safety crisis.
That changes the whole equation. Is there an example of this VOI approach in action?
Yes. One source details a case study involving a needle-free adrenaline autoinjector.
Okay, high stakes right there.
Definitely. Using the VOI framework during their testing, their initial analysis suggested they actually needed a larger sample size than typical, maybe up towards 100 participants.
Wow, that's way more than 5.
Right. But as they collected data iteratively, the VOI analysis also showed them when they reached a point where the expected net benefit of further testing became essentially zero. The cost of testing more wasn't justified by the likely value of the information they gain.
So it helped them start big, but also know when to stop based on diminishing returns in value.
Exactly. It provided a data-driven rationale for stopping, not based on an arbitrary number, but on when the cost-benefit balance shifted.
That's really powerful. You avoid both under-testing and wasteful over-testing.
Mm-hmm. And it ties into this broader idea of monitoring your testing while it's actually happening.
Right, not just setting a number and forgetting it.
Yeah, instead of fixing the sample size up front, you can track your progress. How complete does our problem discovery seem right now?
How do you do that?
Well, one way is using those estimation techniques, like good Turing, to estimate the number of undiscovered problems remaining. If that estimated number drops low enough, maybe you're done, sometimes called a late control strategy.
Okay, using the estimated unknowns as your stopping rule.
But again, you have to be careful. The process has randomness.
Because of who you test when.
Yeah. The order matters. You might get a few really sharp users early on who find loads of problems, making it look like you're finding things fast.
Giving you that false sense of security again.
Or you might hit a patch where users aren't finding much, even if problems are still there. So you can't just look at the raw number found in the last session. You need a more robust view.
Makes sense.
Yeah.
You need to account for that variability.
And related to that, the sources also talk about individual tester differences, not just heterogeneity in problems found, but in the testers themselves.
Also,
Some testers are described as highly sensitive. They just tend to find more problems overall, maybe the more common ones.
okay, the efficient problem finders.
Yeah. And others are more idiosyncratic. They might not find as many problems total, but the ones they do find are unique, things that other testers completely miss.
The ones who find the weird edge cases.
Exactly. And the point is, you need both. Sensitive users help you find the common stuff efficiently, but idiosyncratic users are crucial for uncovering those less frequent but potentially still important issues.
So a good mix of participants brings both sensitivity and idiosyncrasy to the table. It's not just about quantity found, but the breadth and uniqueness of what's found.
Precisely. It contributes to a more complete picture.
Wow. Okay, this has been really illuminating. We've gone way beyond that simple 5-user rule.
Yeah, it's clear that rule is, well, an oversimplification at best, and potentially quite risky, especially for complex or high-stakes products.
So the big takeaway seems to be there's no single magic number.
Definitely not. The right number of users is complex. It really hinges on a bunch of things we've discussed.
Like the product's risk level,
How diverse your users are.
that heterogeneity piece,
How easy or hard the problems are to find the visibility.
and what you're actually trying to achieve with the testing. What's your goal?
Exactly. All those factors play a role.
So the smarter path is what?
Yeah.
A more nuanced strategy.
Yeah. Moving beyond the fixed rule. Using iterative testing, maybe.
Yeah.
Where you test, analyze, decide if you need more, test again.
Using those statistical models and monitoring things like heterogeneity to guide those decisions along the way.
Right. It's a more adaptive, informed approach.
And it seems especially critical for things like medical devices.
Absolutely. For those high-risk systems, being thorough isn't just, good practice for patient safety, which is paramount, but it also makes good business sense for the manufacturers in the long run, avoiding recalls, ensuring market access.
It protects patients and the bottom line. So for you listening, maybe think about how these ideas apply in your world. Are you involved in product development? Do you rely on rules of thumb for testing?
Or even just as someone who uses technology every day, you can see how overlooking these complexities could lead to frustrating or even risky products.
Definitely. Maybe challenge those simple rules. And if you want to go deeper, we really encourage you to check out the research papers we base this on. The links are in the show notes.
Yeah, there's a lot more detail in there about the models and the case studies. It's fascinating stuff.